Assalamualaikum and salam sejahtera. Let's start chapter 4. The topic is forces, and there are two subtopics, which is 4.1 and 4.2, which is basic of forces and free body diagrams and Newton's law of motion. The time suggested here is 1 hour for these two subtopics. Let's start by the first subtopic, which is 4.1. The learning outcome is students should be able to identify the forces acting on a body in different situations, which is weight, tension, normal force, friction, and external force, which is pulling or pushing force. And for the friction, there are two different types of frictional force, which is static frictional force and kinetic frictional force. The symbol is Fs and Fk. Second, students should be able to sketch a free body diagram. And lastly, to determine static and kinetic friction. So, what is force actually? A force is something that is capable of changing an object's state of motion. A force is a push or pull upon an object resulting from the object's interact with other object. Force is under vector quantity. Again, we are discussing about magnitude and direction. And the SI unit of force is Newton, or the symbol is capital N. Okay, let's start by the basic of forces. We need to know how many types of forces do we have for this chapter. Okay, let's start by the first one. The force given is weight. So the symbol of weight is capital W. What is weight? The weight is the gravitational force acting on the body itself, and the magnitude of the weight is given by W equals to mg, where g is the acceleration due to gravity. So normally by giving you mass, we may calculate the weight. Alright, so m representing mass, g is our gravitational acceleration. So by knowing mass, we just multiply by g and then you will get weight. And remember, weight is under vector, it always directed downwards. Alright, for example, by giving you a mass, then how do we calculate the weight? So now if the mass is 2 kg, then since g equals to 9.81 meter per second squared, the weight is, so by using the equation of W equals to mg, the mass given is 2 kg, and then g just a constant, which is 9.81. We just substitute into the equation of W equals to mg, and then you will get weight here equals to 19.62 Newton. Okay, this is the way how do we calculate weight based on mass given. And remember, weight varies slightly with the altitude, because weight depends on the strength of the gravitational field, or G. So normally at different height, the gravitational field strength change already. That is why by having changes in G, then W also change. Alright, so weight varies slightly with altitude. Next force given here is the normal force, where the symbol of normal force is capital N. The normal force is the support force exerted upon an object that is in contact with another stable object. So this is the keyword. It must be in contact with another stable object. And the normal force acts when a body is in contact with a surface. The normal force always directed away from the contact surface and perpendicular to it, or the angle is 90 degrees. Okay, for example, in A, alright, this is the surface and this is the object. So they are touching to each other. The normal force exerted on it just directed upward, where the force and the surface is perpendicular to each other. The angle is 90 degrees. Or according to the second case given here, which is B, this is the surface and this is the object, so that the force exerted now just directed to the right, where the force and the surface, they are perpendicular to each other, or the angle is 90 degrees. Okay, the normal force, also known as reaction force, or the symbol is capital R. Okay, so we have three different cases here. For the first one, this is the object, okay, and this is the surface, so that perpendicular to the surface, okay, what do we have? Just a normal force. In this case, the normal force still equals to weight of the object. Or for the second case, this is the surface and this is the object. So perpendicular to the surface, what do we have now? A normal force, and this is W. And remember, weight always directed downwards. Or for the third case, this is the surface and this is the object. So perpendicular to the surface is the force, which is our normal force. And again, weight always directed downwards. So from this, we may conclude that the normal force or the reaction force is not necessarily always equals to the weight of the object. It depends on the situation. For the first one, N equals to W, of course. But for the second one, N and W, they are different, because in this case we need to resolve W to be WY and WX, so that N equals to WY. So it's not equals to weight. Okay, so again, normal force is not necessarily always equals to the weight of the object. Okay, the next force given here is the tension. So the symbol is capital T. So what is tension? The tension force is the force that is transmitted through a string or rope. So it must be on any string or rope. Okay, or tension is a force in a cord, string that pulls a body, again involving string or cord. Tension always directed away from a body and along the cord. Okay, so remember, directed away from a body. It must be directed outward lah, from any body. And then the tension pulls opposite direction at either end of the attachment with the same magnitude. Okay, what does it mean? Okay, let's say by hanging an object. So this is the object. So remember, according to the first statement, okay, the tension always directed away from a body. So this is the body, then the tension just directed outwards or away from the body. Okay, and then the tension pulls opposite direction at either end of the attachment with the same magnitude. So here we still have tension, but it must be in opposite direction of the original tension before, where the magnitude of these two tension, they are equal to each other. Okay, the next force given is friction, where the symbol of friction is small f. Alright, so what is friction? The friction force is the force exerted by a surface as an object moves across it or makes an effort to move across it. Also known as the retarding force that resists the motion of a body as it slides over the rough surface. Alright, so normally we call it as retarding force against the motion, okay, of for any rough surface. And the frictional force always directed in the opposite direction of the motion. Let's say for any motion which is directed to the right, of course the friction just directed to the left. And then please refer to the diagram given now. Let's say by having a smooth surface, so by giving a small push or little force here, what happened? The friction also smaller here, okay. And then on the rough surface, more force needed to move an object, isn't it? So big push needed here means that the force needed here should be greater than the friction is higher. Alright, so on the smooth surface, it's quite easy for you to move an object, isn't it? But on any rough surface, it's very hard to move an object, so that we need more forces there, or greater forces here to move the object. Then the friction is very high actually. Okay, I think you may refer to the link given here. Based on the video, you may understand it very well later lah. Okay, next, what factor affecting the frictional force? Okay, two factors given here. The first one is type of surfaces in contact. So by having different type of surfaces, the friction also different. Why? Because different surface giving you different coefficient of friction, which is mu. Mu is our coefficient or constant. It depends on the type of surface. So there are two different type mu, which is mu s and mu k. What is that? The coefficient of static frictional force and the coefficient of kinetic frictional force. Okay, so remember it depends on the type of the surface. Next, the second factor is how hard the surfaces are pressed together. So frictional force is directly proportional to the normal reaction, or F is directly proportional to N. How do you get that? From the equation of frictions equals to mu N. The first factor is mu and the second factor is N. So N representing the normal force. When these two objects just press together with greater or stronger force, means that N also greater, isn't it? So for this case, by having greater N, automatically F also greater. So F depends on N, where N now depends on the pressure given here. Alright? Okay, so this is the example. Alright, first, according to the first example now, okay, the foot tries to slip in this direction, which is directed to the left. So that the friction produced now by these two contacting surface, where the friction now just acts in this direction, which is directed to the right. Because as we know, the friction always against the motion. Okay. Still the same for the tire of any car. The tire now is rotating to be like this. So this is the motion of the tire. So this is our contacting surface. So when the motion just backward, the friction must be forward. So this is the friction. The friction always against the motion here. Okay. Alright. So friction between solids is classified into two types, which is static friction, or the symbol is Fs. Okay, exists for any static object only, where the speed or velocity equals to 0. Okay, stationary object. So static friction is the friction force exists between two objects in contact where there is no motion or at rest. Again, this is the keyword, V equals to 0. Okay. Static frictional force may have different values up to some maximum. So the general equation of static frictional force is Fs lesser or equals to mu Sn. Okay, because as we know, the value of Fs now just different values up to some maximum values. So before the object starts to slide, the frictional force or the static frictional force is maximum. Then this is the equation. Maximum static frictional force equals to mu Sn. And normally for any calculation, okay, we just refer to this equation, which is Fs equals to mu Sn. So on that time, the force is maximum because the object starts to slide. Alright, so again, mu S now representing the coefficient of static friction and N now representing the normal force. Okay, and remember the normal force now equals to, we need to check the situation. Is it on the normal surface or inclined surface? Okay. Static frictional force acts in the direction opposite to the direction of applied force. Again, the frictional force again, always in opposite direction of motion. Okay. Next, okay, what do we have now? According to the first example given here, there is no applied force, means that there is no motion, so the box just at rest. So at rest, what happened? Of course, the frictional force equals to 0, or static frictional force equals to 0. The object is really static or at stationary. Second, weak applied force applied on it. Alright, so this is the force applied, the external force exerted on it. But the force is really weak or small. So according to this case, okay, the friction exists now, which is against the motion, so that friction or static frictional force equals to F1, which is the force applied on it. But the box still remain at rest. Why? Because the force is small. Okay, so it doesn't move yet. Alright, C, by applying stronger force, so this is F2, which is stronger than F1 before. So by applying stronger applied force, what happened? So the static frictional force exists here, but remember it must be in opposite direction of the force applied. So in this case, when the force is really greater than the static frictional force is maximum, so that the box just start to slide. So in this case, the frictional force, we call it as maximum static frictional force, equals to Fs equals to mu N. Alright, so the force is maximum lah, or the frictional force is maximum. Okay, next, the second type of frictional force, we name it as kinetic frictional force or dynamic friction, and the symbol is Fk. So before this, we have discussed about any static object, but now we are discussing about moving object. So for any static object, the friction exerted on it, we call it as static frictional force. The symbol is Fs, isn't it? But now for any moving object, the force, now we call it as kinetic frictional force, where the symbol is Fk. So it just at constant speed. Alright, so again, kinetic friction is the friction force exists between two objects in contact where there is relative motion. So this is the keyword. Okay, we are discussing about motion. All right, so the object is moving now. So kinetic frictional force acts in the direction opposite to the direction of motion. Still the same, still in opposite direction of motion, and has a magnitude of kinetic frictional force equals to mu n. And remember, we are discussing about kinetic frictional force, so it must be mu k. Alright, so Fk equals to mu k, and so again mu k is the coefficient of kinetic friction, and n is the normal reaction force. So the values of mu now, which is mu s and mu k, depends on the nature of the surface in contact. So what does it mean? It depends on the type of material. Different material giving you different mu. And in general, mu s is smaller than, mu s is greater than mu k. So that Fs also greater than Fk. Alright, so how to get that? From the equation, which is okay, so as we know the equation before, in general, the equation of friction equals to mu n. So that static frictional force equals to mu Sn, and kinetic frictional force equals to mu Kn. And we know that mu S greater than mu K, isn't it? So automatically Fs also greater than Fk, because F and N, they are directly proportional. Still the same, F and N, they are directly proportional. Okay, so by having greater mu S, then Fs also greater. Alright, so the example given now, alright, the first example, the object now is moving to the right, where the force exerted on it is F1. So as we know, the frictional force, it must be in opposite direction, which is directed to the left. So a box slides at constant speed velocity, then the friction, now we call it as kinetic frictional force, equals to mu Kn. So in this case, F1 equals to Fk. Alright, and then for the second example, a box moves at constant acceleration. Okay, before this, the object is moving under constant speed or velocity, but now the object is moving under constant acceleration. So in this case, the force exerted on it is F2, where F2 is greater than F1 before. Then this is the kinetic frictional force exerted on it, still in opposite direction of the force exerted on it. So in this case, F2 greater than Fk. This is F2, suppose. Alright, why? Because when F2 greater than Fk, then the object may accelerate here. Alright, because the force which is directed to the right is greater than the force which is directed to the left. They are not balanced, isn't it? So that the object may accelerate to the right lah, with acceleration A. According to the first example given before, F1 and Fk, they are equal to each other. So they're just in balance, isn't it? So there is no balance force, then the object doesn't accelerate. Alright, next, okay, this is the example of the coefficient of friction for different materials. And for example, by giving you a rubber, so for any rubber, the coefficient of kinetic friction is 0.80, while its static coefficient of frictional force now is 0.90. Or maybe by taking steel as the example. The coefficient of kinetic friction is 0.06, while the coefficient of static frictional force is 0.10. Okay. So according to the list given just now, we may say that mu s is greater than mu k. See, 0.9 and 0.8, 0.5 and 0.4. So normally mu s is greater than mu k. Alright, and last force given here is the external force. The symbol of any external force is F external. Okay, the external force is a force that exerted on a system or on some of its component by an agency outside the system. And seems like the force just come from the outsider. Alright, the example, applied force, it can be under pushing or pulling force, then the tension, the normal force, and the frictional force. Okay, so this is the example of our applied force, which is under pushing force and pulling force. Okay, so this boy just pulled the object, isn't it? So the force exerted now is the pulling force. Okay, and then the second boy now just push the box. So the force exerted on the box now is the pushing force. And this is our pulling force, and this is pushing force. Alright, so I think we just stop here. Then we just continue by a free body diagram later.